Hey there, it's me again. It's us. I know you got scared. Well, today I'm gonna be talking about eclipses and solar eclipses in particular. You know, solar eclipses when this is the sun, this is the moon, and they pass in. I'm talking especially on total solar eclipses. So the moon totally blocks out the sun. But then you might know that the sun is actually much bigger than the moon. So how can the moon block out the sun? And exactly, perfectly, like not a little more, not a little less, exact on spot. Well, let's see. Here we go. So for this experiment, I have an orange and a lemon. I can juggle. Whoa. Oops. Sorry. Anyways, so what happens is the moon is actually 400 times smaller than the sun. I know this is definitely not 400 times difference, but let's just assume that this is the sun, this is the moon. So, but the moon is also 400 times further away, closer to the earth than the sun. So you see those two, they kind of match. That's why we have a perfect eclipse. And let's test that out. Let's say this is the sun, this is the moon, but the moon is closer to the camera than the sun. So this is going like this. Usually the moon rotates like this. Oh, actually, no. It rotates like this and like this. That's the usual rotation. But let's say now one day, the moon came out. It's the day for a solar eclipse. So the moon came out, and because this is 400 times smaller, but also 400 times closer. When the moon comes, it perfectly blocks out the sun. I know, sorry that the moon is yellow, but actually the sun isn't really yellow, it's white. Yeah, I know. I'll make a video on that maybe. Anyways, see how it perfectly blocks it out? But since both the sun and the moon are moving, it doesn't last for very long, and they're really rare, like once or twice a year. And you might notice that if the moon was a little bit closer to you, it'll be too big. Or if it was further away, then the sun would still come. And that's why the 400 times smaller but 400 times closer, it's so accurate to the meter. Well, I don't know if it's actually accurate to the meter, but it's really accurate. So accurate, it just covers out in the kind of quote-unquote atmosphere of the sun. Astronomers are able to see it. But if the moon was too close, then it would even block out the atmosphere. And if it was too close, then it would not block out the entire sun, because the glare of the sun can't make astronomers see the sun. So they have to wait for an eclipse. And it's so perfect. Well, see you later, alligator. I can't juggle. I have to juggle. It's alright. See you later, alligators.